Computational Introduction to Robotics gets you into the field of robotics, but through a computational perspective. So the idea is to understand what are sort of the software engineering techniques you apply to create robots that do things in the world, what are the algorithms that you use to make intelligent robots, and ultimately how do you evaluate and make sense of the likely impacts that robots might have on the world. The students are all at least in their second year, and students might take it at different points on their academic journey. They might be looking for a little bit more depth in their computing concentrations, or they might be more senior robotics students that are looking to, get better at programming robots. Robotics are this really challenging area where you have to bring together a bunch of different disciplines in order to program them and get them to act in the world. So I want students to be able to figure out how they're going to solve a particular task by writing software for their robot, be able to come up with an approach, so articulate how they're gonna solve the problem, successfully implement it, and then be able to test it. And then the last part of that is to be able to actually think a little bit more critically about how this might connect to sort of larger trends that are happening in the field. So, robots are an area that are, impacting our lives more and more each day. Areas from agricultural impact to sustainability to warehouse robotics, self-driving cars, augmented reality, all these areas that are kind of the next wave of big technological advances are all pull from robotics as like a core discipline. Students have the ability to really understand what is underneath the hood of those technologies and actually implement some of them themselves and start to get a sense of what those impacts might be and how their own decisions might influence the nature of those impacts. That's really where the course lies. We try to tie together the technical work with the ethics. We don't want students to kind of compartmentalize their knowledge. We try to help students come to whatever conclusions, are consistent with their values. Ultimately, it's their decision to make what their personal stance is on these issues, but we just want to try to give them some tools and some information to think it through. And so this happens, really naturally in the class because these two streams are really well tied together, the ethics and the technical component.
Yeah, so here's a camera looking out, and we know this distance right here.
Yeah, you know that distance because we can just measure it.
Right.
You see these really beautiful outcomes in the course where you see students that are technically brilliant individually and they're able to come up with great ideas, but then you see them combine together and do some really amazing things. I saw students splitting up, doing independent research on ideas, coming together, discussing them, raising questions with me, asking questions of their peers, and all of this sort of communication and the ability to sort of do self-directed learning kind of all came together in an absolutely fantastic final project. Some of those students have gone on to some of the best grad schools and are currently working in the field of robotics, so it's really fun to hear from them again and about all the great stuff they're doing. I love seeing the students develop critical thinking skills and the ability to come up with an approach to a problem that makes sense, successfully bring it into being, and then be able to understand if it's working and improve it, and actually have the skills to look back at their work and examine it and try to understand what they could improve and what could change. And that's very cool because that's the type of perspective you don't often get until you're well into grad school or well into your professional life.